High-speed rail in the United Kingdom. High-speed rail in the United Kingdom is provided on 5 upgraded railway lines running at top speeds of 125 mph 200 km/h and one purpose-built high-speed line reaching 100. Trains currently travel at 125 mph 200 km/h on the East Coast Main Line, Great Western Main Line, Midland Main Line, parts of the cross-country route, and the West Coast Main Line. On the latter line, only tilting trains can reach this maximum speed due to the difficult track geometry. The 67-mile-long high-speed 1H line connects London to the Channel Tunnel, with international Eurostar services running from London St Pancras International to cities in France, Belgium, and the Netherlands at 186 mph 300 km/h. That line is also used by high-speed commuter services from Kent to the capital, operating at top speeds of 140 mph 225 km/h. Since 2019, construction has been ongoing on a major new purpose-built high-speed rail line, High-Speed 2 Hs2, which will link London with major cities in the North and the Midlands at 224 mph 360 km/h and reduce journey times to Scotland. Government-backed plans to provide east-west high-speed services between cities in the north of England are also in their early stages of development as part of the Northern Powerhouse Rail project. There has been no single national rail operator in the UK since British Rail was privatised in the 1990s. High-speed services are provided by Avanti West Coast, Cross Country, East Midlands Railway, Eurostar, Grand Central, Great Western Railway, Hull Trains, London North Eastern Railway, Lumo, Southeastern, and TransPennine Express. History. High-speed steam. During the age of steam locomotion, the British railway industry strove to develop reliable technology for powering high-speed rail services between major cities. The earliest attempt to build a railway line dedicated for operation at the higher speeds was the Great Central Main Line, opened by the Great Central Railway (GCR) in 1899. This line was an ambitious project led by railway entrepreneur Sir Edward Watkin, who envisaged a Liverpool-Paris route crossing from Britain to France via a proposed Channel Tunnel. Although the tunnel scheme was not realised by this railway company, the route operated services between Sheffield Victoria and London Marylebone via Leicester Central, with a dedicated express track beginning at Annesley in Nottinghamshire. The line was built to certain specifications so that it could take advantage of the higher speeds offered by the advances in steam locomotion. For most of the line, the ruling gradient did not exceed 1 in 176 5.7%. 0 outside urban areas. Wide curves were employed with a minimum radius of 1 mile. The route only had one level crossing, and, unlike other railway lines in Britain, the Great Central Main Line was built to an expanded continental loading gauge. The GCR target market was higher-class business travelers, and it promoted its long-distance express trains with the slogan "Rapid Travel in Luxury." Most of the Great Central Main Line closed in 1966 as part of the beaching cuts, although parts of the route are still in use today. According to plans announced in 2010, part of the proposed high-speed 2 Hs2 route will run along a reopened 10-mile 16 km section of the GCR route between Calvert and Brackley. An alternative proposal to reopen the GCR for freight has been put forward by the Central Railway Company. Various claims exist for the first locomotive to break the 100 mph 160 km/h barrier, notably the Great Western Railway's City of Truro 1904 and the Elmers Flying Scotsman 1934. Locomotive power capable of reaching 126 mph 203 km/h has existed in Britain since 1938, when the Elmers Mallard broke the steam locomotive speed record. Despite advances in locomotive engineering, the railway infrastructure was unable to support safe running at such high speeds and, until the mid-1970s, the British railway speed limit remained at 100 mph 160 km/h. The apt In the 1970s, British Rail began to explore new technologies for enabling high-speed passenger rail services in the UK, while the Japanese and French railway authorities had decided to build completely new tracks for their respective Shinkansen and TGV high-speed rail systems. British Rail opted instead to develop a train capable of running on existing rail infrastructure, the Advanced Passenger Train APT, with a top speed of 155 mph 249 km/h. An experimental version, the APT, was tested between 1972 and 1976. It was equipped with a tilting mechanism which allowed the train to tilt into bends to reduce cornering forces on passengers, and was powered by gas turbines, the first to be used on British Rail since the Great Western Railway, and subsequent Western region utilized Swiss-built Brown Bovary and British-built Metropolitan Vickers locomotives 18,000 and 18,100. The 1970s oil crisis prompted a rethink in the choice of motive power, as with the prototype TGV in France, and British Rail later opted for traditional electric overhead lines when the pre-production and production APT were brought into service in 1986. Initial experience with the advanced passenger trains was good. They had a high power-to-weight ratio to enable rapid acceleration. The prototype set record speeds on the Great Western Main Line and the Midland Main Line, and the production versions vastly reduced journey times on the WCML. The APT was, however, beset with technical problems, financial constraints, and negative media coverage eventually caused the project to be cancelled. Intercity 125. During the same period, British Rail also invested in a separate, parallel project to design a train based on conventional technology as a stopgap. The Intercity 125, otherwise known as the high-speed train Hs2, was launched in 1976 with a service speed of 125 mph 201 km/h and provided the first high-speed rail services in Britain. The Hs2 was diesel-powered, and the Great Western Main Line Gwml was the first to be modified for the new service. Because the Gwml had been built mostly straight, often with 4 tracks and with a distance of 1 mile ca. 1.6 km between distant signal and main signal, it allowed trains to run at 125 mph 201 km/h with relatively moderate infrastructure investments compared to other countries in Europe. The Intercity 125 had proven the economic case for high-speed rail, and British Rail was keen to explore further advances. Intercity 225. BR then proceeded to electrify the Gwml and ordered a new fleet of Intercity 225 electric trains in the mid-1000s. These were capable of 140 mph 225 km/h and, although not initially equipped to tilt, were designed to be easily upgraded to tilt mode by having trailer profiles that tapered inwards at the top and suitable bogies. Speeds of 140 mph 225 km/h were tested on the southern, straighter sections of the Gwml by using a flashing green aspect on the signals. This indicated it was safe to proceed above 125 mph 201 km/h, but HMRSI eventually ruled that this was dangerous and that speeds above 125 mph would require in-cab signaling. The 225s were therefore limited to 125 mph 201 km/h and have been ever since. High-speed DMU, 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 WU, DMU, WU, DMU, WU, DMU. In the early 2000s, a number of train operating companies introduced diesel multiple units DMU capable of 125 mph 201 km/h speeds, including the Adelante, Voyager, Super Voyager, and Meridian/Pioneer units. Pendolino. In 2002, Virgin Trains West Coast introduced a new high-speed service on the West Coast Main Line with a fleet of 53 custom-designed Pendolino trains. The 9-car trains were constructed by Alstom and are equipped with a tilting mechanism developed by Fiat to enable them to run at high speeds on existing rail infrastructure, thus fulfilling the aims of the APT project some 30 years later. The Pendolinos were designed to run at 140 mph 225 km/h, but require in-cab signaling for high-speed operation. The 2004 West Coast Main Line modernization program, which was an upgrade to the infrastructure to allow faster line speeds, ran over budget, and plans were consequently scaled back. As with the introduction of the Intercity 225 in the 1980s, the lack of signaling upgrades resulted in the maximum line speed being restricted to 125 mph 201 km/h. Some members of the fleet were later lengthened to 11 carriages. Current high-speed trains. The following table lists the speeds of the fastest trains operating in Great Britain in 2020 which are capable of a top speed of 125 mph or greater. High-speed 1H zone. The Channel Tunnel Rail Link Control, now known as High-Speed 1H zone, was the first new mainline railway to be built in the UK for a century and was constructed by London and Continental Railways. After a lengthy process of route selection and public inquiries in the second half of the 1990s, work got underway on Section 1 from the Channel Tunnel to west of the Medway in 1998 and the line opened in 2003. Section 2, continuing the line to London St Pancras, started soon after Section 1 and was opened to the public on 14 November 2007. The H-Zone line was finished on time and under budget. The reduction in journey times and increase in reliability achieved through the opening of Section 1 enabled Eurostar to capture 71% of the total London-Paris market and over 80% of the leisure market. Additionally, the connections provided to the WCML, MML, and ECML by Section 2 may see growth of hitherto marginal markets by finally allowing regional Eurostars to operate, at least on the electrified ECML and WCML. Market share statistics of Eurostar on London-Paris punctuality between brackets. September 2006 July September 91.4%, August 2005 71.3%, January September 87%, May 2005 69%, August 2004 67.87%, January December 84%, July 2004 65.88%, January June 89%, October 2003 65%, July 2003 60.23%, January June 77%. The completion and successful operation of H-Zone Sections 1 and 2 spurred much discussion and several proposals for new line. These proposals are discussed below. The construction of H-Zone also permitted the introduction of a new domestic high-speed service when in 2009 Southeastern launched its high-speed route between London St Pancras and Ashford International. Operated with a fleet of Class 395 trains, the service reaches a top speed of 140 mph 225 km/h. Southeastern High Speed is currently the only British domestic high-speed service allowed to run above 125 mph 201 km/h. High-Speed 2 Hs2. High-Speed 2 Hs2 is a high-speed railway originally designed to serve London, Birmingham, Sheffield, and Leeds, or alternatively London, Manchester, Liverpool, Preston, Glasgow, and Edinburgh, and Sheffield. The UK government launched a formal high-speed rail project in January 2009, and high-speed rail has the support of all three main political parties. Subject to consultation, the London terminus for the high-speed line would be Euston. A new Birmingham city centre station would be built at Curzon Street, and there would be interchange stations with the Elizabeth line at Old Oak Common and with the existing Intercity rail network near Birmingham Airport. HS2's original proposal was for a Y-shaped network between London and England's major regional cities, serving Manchester, Birmingham, Leeds, East Midlands and Newcastle, with connections onto the West Coast and East Coast main lines to allow through services to Scotland. The Green Gauge 21 study states that the total route length, including the connections to the existing network and high-speed 1, would be 150 miles 240 km. The first phase of high-speed 2 is currently under construction. However, the Integrated Rail Plan for the North and Midlands IRP was published on 18 November 2021 and impacted the high-speed 2 plan. Studies and proposals. In 2001, two privately sponsored proposals were put forward to build high-speed lines in the UK. The first, from Virgin Rail Group, was part of its tender for the Intercity East Coast franchise. The second, from First Group, was independent of the Department for Transport/Strategic Rail Authority rail franchising process. Neither was welcomed by the government, which in the wake of the Hatfield rail crash was focused on as it saw it getting the rail network back to reliable operations. Virgin Trains Gwml bid. When the Intercity East Coast franchise, then operated by Ur, came up for its first renewal, Virgin Rail Group raised the idea in 2000 of constructing new track and purchasing a new fleet of trains for the line. These so-called VGV, Virgins Grand Vitus, after the French TGV, would have been capable of 330 km per hour, 210 mph, and would have used a mixture of new track and existing track. The new track would be from Peterborough to Yorkshire and on from Newcastle to the Scottish border. This first line would have opened in 2009 and was chosen for ease of construction in the south and elimination of severe curves in Northumberland. Later, if successful, further stretches would have been upgraded. Publicity material featuring Virgin branded TGV and IC trains appeared, and it was stated that the stock would be built in Birmingham. Virgin's bid was rejected, and Nur's franchise was renewed. First Group's plans for the Gwml corridor. Around the same time, First Great Western, operator of lines west of London, first sponsored the study, and input was given by other stakeholders in the regions to be served. Journey times from London given included Swindon 35 mins, Bristol Parkway 49 mins, Cardiff Central 70 mins, Swansea 120 mins, Plymouth 140 mins, although first stated that this report would be published and given to the SRA and government, little has been heard of the plan since the initial press release. In 2010, Cardiff City Council again lobbied central government for a high-speed rail line to London via Bristol, then estimated to contribute £2.02 billion to the Welsh economy. The Department for Transport responded to this bid by stating that the government's vision is of a truly national high-speed rail network for the whole of Britain. However, given financial constraints, we will have to achieve this in phases. Ministers are currently considering Hs2 Ltd's proposals in respect of the potential first phase of such a network. Government commissioned studies. Since the completion of Section 1 of the Hs2, government departments and ministers have commissioned reports into the viability of high-speed rail. This is in part due to the success of the Hs2 project, part due to realization that upgrades to existing infrastructure offer poor value for money and cannot hope to meet future capacity needs, and part due to increasing environmental concerns over the expansion of the short-haul airline industry. Atkins Study. In 2001, the SRA commissioned Atkins to perform a feasibility study into the transport and business case for high-speed rail. The study, published on 29 October 2004, looked at combinations of 11 routing options to accommodate forecast traffic flows and concluded new capacity is required to relieve the WCML by 2015. Further new capacity will be required to relieve all three north-south routes by 2031. Construction of the complete proposed network would cost £33 with the shortest option £10 with. The line would give a cost-benefit ratio of between 1.9 and 2.8 to 1. Furthermore, additional work was done to look at the impact of road pricing, downgrading the enhancements to the Gwml and changes to the Treasury's Green Book method of assessing project finance. All three areas were found to improve the case for high-speed rail. Atkins Option 1. The Atkins study proposed a line between London and Stoke-on-Trent, broadly following the existing WCML and using the WCML for onward connection as its baseline scenario. Atkins Option 8. The study concluded that new lines should be built each side of the Pennines, with the Eastern Line continuing to Edinburgh and Glasgow. A branch also serves Heathrow Airport. This is the £33 on an endgame scenario. Atkins Option 10. The study considered a link between Manchester and Leeds but did not take this forward. Commission for Integrated Transport. In 2004, the Commission for Integrated Transport commissioned Steer Davies Gleave to produce a report on high-speed rail. The report focused on the reasons why the costs being quoted for British HSR routes, particularly in Atkins, were high in comparison to other countries, in addition to investigating the business case and transport case for such a network. The routes studied gave hypothetical journey times from and to London as follows. The study gave the following recommendations: that the government and SRA begin to plan now for high-speed rail HSR as part of a wider strategy to ease the anticipated capacity constraints on the existing networks. Schemes that appeared to offer good value for money should be actively progressed. That costs of HSR projects be closely examined to bring them closer to the lower costs achieved in Europe. They should take account of possible reductions in underlying costs and further cost reductions if the industry structure, safety regulations, and the approvals process were reviewed. That the government examine ways of maximizing private sector involvement in HSR. This should take account of the potential impact of any future national road charging scheme on passenger demand and its potential to make private sector investment more attractive. That changes in the appraisal process be considered relating to value of time, economic impact analysis, environmental assessments, and risk/optimism bias allowances. Additional capacity would be required by 2015. Ways to reduce the currently high cost of new rail infrastructure such as high-speed lines included. Building lines in phases rather than all at once could produce a cost saving of 20% minus 30%. British project management, planning, design, and legal costs can reach 25% of the total cost compared with 3% on the Spanish Madrid-Lerida line and could therefore be reduced. If these cost savings materialized, then the benefits could outweigh the costs by 3 to 1. Eddington Report. In 2006, British Airways former Chief Executive Sir Rod Eddington produced a report on future transport strategy. The report covered all transport modes and had initially been expected to strongly recommend investment in high-speed rail. However, on 29 August 2006, The Times reported that Sir Rod would state that given a limited transport budget, a high-speed rail link is not the most cost-effective option to obtain higher capacity on the rail network, and therefore should not be built. Most of the press continued to take this line when the report was finally published, drawing scorn from both opposition parties, Labour backbenchers, and transport pressure groups alike. The report seemed to confirm this. Significant momentum has built behind the case for a new network of very high-speed rail lines in the UK. This is often associated with new technologies, such as magnetic levitation devices, currently in very limited use in China. The business case is often argued to rest on the transformational impact of such a network on the UK economic geography. However, new high-speed rail networks in the UK would not significantly change the level of economic connectivity between most parts of the UK, given existing aviation and rail links. Even if a transformation in connectivity could be achieved, the evidence is very quiet on the scale of resulting economic benefit, and in France business use of the high-speed train network is low. Faced with such arguments, supporters of HSL point to the capacity increases such new lines would deliver in London and selected urban areas by removing some or all interurban trains from commuter and freight lines. Such benefits are likely to be both real and substantial. Crucially, though, these goals could be achieved by other solutions, and perhaps at much lower cost. The range of policy measures would include fares pricing policy, signal-based methods of achieving more capacity on the existing network, and conventional solutions to capacity problems, e.g. longer trains. Indeed, in keeping with a non-modal approach, the measures assessed should include improvements to other modes that support these journeys, e.g. motorway, bus, and urban access improvements. New lines, including new very high-speed lines, should take their place within this range of policy measures, and each should be assessed on their merits before selecting the option that offers the greatest returns on investment. An alternative argument is sometimes made on environmental grounds because a very high-speed line from London to Scotland could attract modal shift from air. Such arguments must be made with care given that total domestic aviation emissions, including flight between other cities, account for 1.2% of the UK annual carbon emissions, see OPWO equivalent, including allowance for the climate change impacts of non-carbon emissions from aviation. Furthermore, rail's energy consumption and carbon emissions increase with speed, and this would erode rail's environmental advantage, and so it is important to consider the costs involved in reducing carbon emissions in this way. However, Sir Rod later claimed both to the press and to a parliamentary select committee that he was quoted out of context in reports at the time, had aimed his comments specifically at speculative maglev options, and in fact was in favor of using conventional high-speed rail to relieve congestion once existing main lines reached capacity. Indeed, the quotation refers specifically to very high-speed lines. Nevertheless, enthusiasm for such projects seemed to wane after the report's publication, at least in Westminster. The topic remained much on the political agenda in the northeast of England and Scotland. Gwml 21 study. In June 2007, the campaign group Gwml 21 published a proposal for high-speed 2. It evaluated options for high-speed rail in the UK and recommended an £11 route from London St Pancras and Heathrow to Birmingham and the North West, which they dubbed Hs2. The report recommended the new line be built in the M40/Chiltern Main Line corridor and used it as the basis for its findings. This route has the greatest strategic advantage, as the Chiltern Main Line is a popular alternative to the WCML from Birmingham to London, and also lends the opportunity to build a branch line to Heathrow Airport, giving the passengers served by the WCML a direct service to one of the world's premier international airports. The WCML is also the corridor which would be under the most pressure in the next 15-20 years. A connection to high-speed 1 would allow Eurostar terminals to open in Birmingham and Manchester. Branching off Hs2, it would briefly follow the WCML and GWML, branching off at the connection with the Central Line, going to Northolt Junction, where it will follow the Chiltern Main Line, and have a triangular junction serving a branch to Heathrow. The line will be tunneled at Chiltern stations up till Princes Risborough, where it will incorporate itself with the Intercity line, up to Banbury, where it will branch off and hug the M40 and M42 before joining the Birmingham Loop at Birmingham International/Intercity. Links to Milton Keynes and Oxford via the Varsity line and Banbury in the middle of the line would experience a growth in services. Local services on Chiltern, WCML south of Rugby, and Banbury Coventry Birmingham could be intensified. The new line would enable journey times of London to Birmingham in 45 minutes, Birmingham to Paris in 3 hours, London to Manchester via the WCML after the Trent Valley in 1 hour 30 minutes, Manchester to Paris in 3 hours 45 minutes. The line would be built to the continental loading gauge, allowing the use of double-decker trains. On 3 July 2007, reports appeared in several British newspapers about the UK government's forthcoming 30-year strategy, see below. It was stated that Britain may need high-speed too, but that the strategy will stop short of promising to pay for the line. In September 2009, Gauge 21 published a new study into high-speed rail. This was far more extensive than Network Rail's proposal, calling for a full integrated high-speed network totaling around 1,500 km. Greengage's plan calls for two north/south corridors from London, which would broadly parallel the Gwml and WCML, together with three east/west corridors between London Bristol, Sheffield Manchester, and Edinburgh Glasgow. Both the north/south lines would consist of new-built high-speed lines, while the east/west corridors would run on existing lines upgraded to allow 200 km/h running. One of the central parts of the Gauge 21 proposal is to have it linked directly with High Speed 1 to allow through running to the Channel Tunnel, thus enabling trains to run direct from regional cities to Europe. The draft timetable produced as part of the plan estimates that trains could run between Birmingham and Paris in approximately 3 hours. High-speed northeast. The northeast route would run north from London to Cambridge, with a spur connecting to Stansted Airport and beyond into East Anglia, joining up with Great Eastern Main Line at Ipswich and diverting from Stansted towards the East Midlands, stopping at Nottingham and Sheffield. It would then run as far as Leeds, before resuming the route of the Gwml towards Newcastle. Between Newcastle and Edinburgh, the route would consist of existing upgraded line rather than new build. High-speed north-west. The northwest route would be completely new build. This would run north towards Birmingham, with a spur to Heathrow Airport, before reaching Manchester and Liverpool. Both of these would be on branches off the main line, with Manchester at a triangular junction. The main line would continue north where it would fork, with branches to Glasgow and Edinburgh, where it would connect with the northeast line. High-speed west. The western corridor would consist of existing track upgraded to 200 km/h and would run west out of London, stopping at Heathrow, Bristol, and Cardiff. A triangular junction at Heathrow would allow access from these western destinations to the northwest route without the need to go via London. High-speed Transpennine. The Transpennine route would be a short corridor of upgraded line connecting Sheffield and Manchester. Both of these would be on triangular junctions, allowing access to all destinations on the northeast and northwest corridors. High-speed Scotland. The Scottish route would be a corridor between Edinburgh and Glasgow, consisting of entirely new-build line. Government White Paper, Delivering a Sustainable Railway. In July 2007, the new Transport Secretary, Ruth Kelly, delivered a white paper on the future of the railways. The report outlined the government's strategic plan for the railways until 2037, which recommended further study and stated that dedicated magnetic levitation system and freight lines were too expensive. Amongst the support documentation for the white paper was a report by transport professors Roderick Smith and Roger Kemp. Second Atkins Study. In March 2008, The Observer and the Sunday Times both reported that a second report for the Department of Transport by Atkins entitled Because Transport Matters showed that the original option ate a high-speed network on both west and east coasts, well in excess of the predicted costs of £31 an. The report suggested building two 300 km per hour 190 mph lines on the east and west coasts. The West Coast line would run to Manchester, and the East Coast line would run to Edinburgh and Glasgow. Travel times of 71 minutes to Manchester and 74 minutes to Sheffield were mentioned in the report. Network Rail Study. In August 2009, Network Rail published a study outlining its proposals for the expansion of the railway network. The headline proposal was its plan for a new high-speed rail line between London and Glasgow/Edinburgh, following a route through the West Midlands and the northwest of England. This plan, whereby the new line would follow a similar but not totally parallel route to the West Coast Main Line, would involve trains running from both London and Birmingham as southern termini to Manchester, Liverpool, Glasgow, and Edinburgh. Included in the report are draft timings which put Birmingham less than an hour from London, Manchester just over an hour, Liverpool just under 90 minutes, and just over 2 hours to Glasgow and Edinburgh, with 16 trains per hour estimated from London and 4 trains per hour between the regional cities. The report also looked into the question of services to Heathrow Airport and came to the conclusion that running all trains from London via Heathrow reduced the benefit of the line by as much as £3 billion. Instead, Network Rail's proposal would entail a short spur from the main line terminating at Heathrow, reducing the road and air traffic to the airport from the cities that the line would serve. Network Rail also outlined the case for not including such areas as Leeds and the northeast of England in the proposal, with 2 main points. The journey time from London to Leeds via Manchester would not be reduced significantly enough over the existing route via the East Coast Main Line to warrant the cost of building the connection. Leeds would be the top target market for any proposed high-speed line from London to northeast of England, so building a connection to Leeds would reduce the strength of the case for that. Beyond Hs2 Report. In May 2018, Greengauge 21 released a report entitled Beyond Hs2, which looked at how the rail network could develop by 2050. It proposed several projects: new high-speed line from Colchester and Cambridge via Stansted to Stratford, possibly extending to Canary Wharf; a new higher-speed line from Perth and Dundee to the Shotts Line; a new high-speed line avoiding Motherwell; a new connection between the Hs2 eastern leg and Kingsbury allowing services to continue to Bristol, Cardiff and Plymouth via Cheltenham Spa; a new link between Gwml and Crossrail; a new link between Langley and Heathrow; a new link between Richmond and Waterloo to Heathrow T2; a new link between Heathrow and Staines; a new Northern Powerhouse Rail; a new line between Darlington and Newcastle; Northern Powerhouse Rail Hs3. In June 2014, the then Chancellor of the Exchequer, George Osborne, proposed a high-speed rail link high-speed 3 Hs3 between Liverpool and Newcastle/Sheffield/Hull. The line would utilize the existing route between Liverpool and Newcastle/Hull, and a new route from to Sheffield will follow the same route to Manchester, Victoria, and then a new line from Victoria to Sheffield, with additional tunnels and other infrastructure. Osborne suggested the line should be considered as part of a review of the second phase of High Speed 2. Initial estimates suggested a rail line with a 140 miles per hour 230 km/h line speed and Leeds-Manchester journey times reduced to 30 minutes. Osborne estimated the cost to be less per mile than that of Hs2, giving a cost of under £6 billion. Initial responses to the proposal were mixed. Jeremy Acklam of the Institution of Engineering and Technology (IET) suggested that plans should look at connecting other northern cities, such as Liverpool, and potentially northeast England via York. However, the British Chambers of Commerce (BCC), Confederation of British Industries (CBI), and others were cautiously positive about the proposal, but emphasized the need to deliver on existing smaller-scale schemes. Heathrow Airport to Gatwick Airport high-speed 4 Air. In 2011, the Department for Transport confirmed that ministers were studying a proposal for a 180 mph line between London Heathrow and Gatwick airports. The journey would take 15 minutes and provide the first direct rail link between the two airports. The plan could virtually make Heathrow and Gatwick into a single hub. In 2018, a proposal was put forward by a British engineering consultancy, Expedition Engineering, for Hs4 Air, a high-speed railway line that would run to the south of Greater London, creating a 140 km link between Hs2 and Hzone via Heathrow and Gatwick airports. High-speed trains. Future trains. After units such as the Intercity 125 were retired, GWR replaced them with Class 800 and Class 802 Hitachi units. Elmer replaced their units with Class 800 and Class 802 units. East Midlands Railway replaced theirs with Class 180 units as an interim solution until Class 810 units are built. Avanti West Coast are replacing their Class 220 and Class 221 Bombardier Voyagers with new Hitachi Class 805 and Class 807 units. Trans-Pennine Express decided to move from operating commuter trains to high-speed trains, with Class 802 and Class 397 units coming in. These units allowed Trans-Pennine to begin services up the East Coast Main Line to Edinburgh from Manchester Piccadilly. Lumo is a new operator that will commence in October 2021. It will operate Class 803s built by Hitachi up the East Coast Main Line from London King's Cross to Edinburgh Waverley. High Speed 2 will have some new trains. The bidding process included Alstom, CAF, Hitachi, Siemens, and Talgo. In December 2021, the contract for Hs2 rolling stock was awarded to a joint venture between Hitachi Rail and Alstom for a development of the Zefiro 300. Intercity Express Program IEP. On 8 March 2007, the Department for Transport invited bidders to participate in the Intercity Express Program, or IEP. This is a project to replace the aging Intercity 125 and subsequently Intercity 225 fleets with a new high-speed train designed to operate on the Gwml, Gwml, and cross-country routes. The project grew out of discussions between First Group and Siemens in the early years of the decade, later being taken over by the SRA and DFT. On 12 February 2009, the DFT announced that Agility Trains, a consortium led by Hitachi, was the preferred bidder with a train named the Hitachi Super Express. In February 2010, it was announced the program was suspended pending an independent report, with a decision on its viability to be given after the 2010 general election. HSR promoters. The recent interest in high-speed rail generated by the success of the control has led to the formation of several companies and non-profit groups aiming to further the construction of domestic high-speed lines in Britain. The principal groups are Green Gauge 21. Green Gauge 21 is a non-profit group aiming to establish conventional high-speed wheel-on-rail technology as the mode of choice for new lines. The group has performed studies on routing, environmental issues, and the use of high-speed rail as an alternative to short-haul airlines. Currently, it is proposing a new high-speed line between, at first, London and Birmingham. This is tentatively called High Speed 2. 11 Cities Campaign. 11 big cities announced a joint campaign for a high-speed rail network serving the entire of Great Britain on 9 September 2009. Birmingham, Bristol, Cardiff, Edinburgh, Glasgow, Leeds, Liverpool, Manchester, Newcastle, Nottingham, and Sheffield stated as their goal that the campaign will be deliberately focused on the importance of building a whole network to link all our major economic centres together, not simply a sterile debate about where a first route should go. High Speed UK. 2 railway engineers have proposed an alternative network to Hs2, which they claim would provide higher connectivity and 25% lower cost than Hs2. Other developments. Liberal Democrats' plans for British high-speed rail network. On 2 August 2007, the BBC reported that the Liberal Democrats proposed the building of a high-speed rail network in Great Britain connecting London with Birmingham, Leeds, Manchester, Tyneside and Scotland in the north, and Bristol, Cardiff and Exeter in the west. Funding for the investment would come from an extra £10 per ticket on internal flights in Britain and tolls on road freight, mirroring similar toll schemes in Germany, Austria, Switzerland, and the Czech Republic. On 22 August 2007, a Scottish Liberal Democrat MSP tabled a motion to the Scottish Parliament calling for a high-speed rail link between Edinburgh, Glasgow, and London. Conservatives' plans to force short-haul passengers onto high-speed rail. On 28 August 2007, The Times reported that the Conservative Party has found that 20% of all flights from Heathrow are to destinations that can be or soon will be able to be reached in a competitive time by high-speed rail. The top 10 short-haul desks: Paris, Amsterdam, Edinburgh, Manchester, Brussels, Glasgow. They plan to impose a moratorium on airport expansion and force this traffic onto the railways, freeing up slots for long-haul flights and removing the need for a third runway at Heathrow and a second runway at Stansted. Arup publishes plan for HS2. Ooh, 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 ooh. On 2 December 2007, the Sunday Times reported that engineering group Arup, a member of the consortium behind High Speed 1, was to put forward a plan for a second British high-speed line to the north of England and lowland Scotland via Heathrow Airport. This would enable direct transfers between flights and trains to continental Europe and British regions. The plan, closely resembling that of Green Giga 21, was to be formally announced later in week commencing 3 December 2007. Accidents and incidents. Southall rail crash on 19 September 1997. A Great Western Trains Intercity 125 operating a service from Swansea to London Paddington failed to stop at a red signal and collided with a freight train entering Southall goods yard. 7 people were killed and 139 were injured. The train driver, Larry Harrison, was charged with manslaughter. He had been distracted as he had bent down to pack his bag, but the case was dropped. Great Western Trains was fined £1 5 million for violations of health and safety law in connection with the accident.